Let's take a look at adding, subtracting, multiplying, and dividing rational numbers expressed as fractions and decimals. A lot of this is we've seen before, but they're just kind of putting it in a different terminology. So let's look at our first problem. It says write each rational number in lowest term. They're referring to it as a rational number. We're used to some earlier sections calling it fraction. So we got negative 54 over 60. Now remember, what we do is we look at top and bottom, and we look for the largest number to divide into both of those. Well, these are both divisible by 6. So I'll take negative 54 divided by 6, and 60 divided by 6. Well, that gives us a negative 9 up on top, and down below, 60 divided by 6 gives us 10. So our answer is negative 9/10. We've seen those before. This next one's new. It wants us to multiply these numbers together. So we got 6/8 times 14 24ths. And this is multiplying fractions. Now they call it rational numbers. It's multiplying fractions. Our first step, simplify. And it says if you can divide a number on top of a fraction and a number on the bottom of the fraction by the same number, do so. So if you can divide a number on top of a fraction and a number on the bottom of a fraction by the same number, do so. Now they can be in the same fraction or they can be in different fractions. It doesn't matter. Just as long as one's on top, one's on the bottom. And it's multiplication. Well, here's 6 and 24. Those are both divisible by 6. 6 divided by 6 is 1. 24 divided by 6 is 4. And again, I'm looking for something I can divide. Here's 14 and 4. They can be in the same fraction, they can be in different fractions, just as long as one's on top, one's on the bottom. These are both divisible by 2. 4 divided by 2 is 2. 14 divided by 2 is 7. So that gives us 1/8 times 7 over 2. Now 2 and 8 looks like I could do something with those, but remember our guide. One's on top, one's on the bottom. Other than that, we don't have a rule on simplifying, assuming they can both be divided by the same number. So our second step. Multiply the tops and multiply the bottoms. When we do this, we're going to put them into a single fraction. So 1 times 7 is 7, 8 times 2 is 16. So our answer is 7/16. If you've done a good job in simplifying on step 1, you don't have any simplifying at the end on these. Yeah, let's look at another multiplication. Got 8 times 3 over 16. Well, if I'm going to multiply, if I'm going to add, subtract, divide fractions, any of the above, they both should be fractions. So I want to rewrite the 8 as 8 over 1. And now we'll go through our steps. We'll simplify. I notice 8 and 16, these are both divisible by 8. 8 divided by 8 is 1. 16 divided by 8 is 2. So we have 1 over 1 times 3 over 2. Now there's nothing else to simplify, so I'll multiply top parts together. 1 times 3 is 3, and the bottom parts, 1 times 2 is 2. So our answer is 3/2. Now we looked at this next topic in the last section, but it's used here, so let's reintroduce it. It says find the reciprocal of each number. Well, reciprocal just means fraction flipped. So 7/8 becomes 8/7. So again, you just flip them. Well, let's take a look at some division. Got 5 halves divided by -8/15. And this is dividing fractions. Step 1. Rewrite as multiplication. We never actually divide, we immediately rewrite as multiplication by changing the negative to times and flipping the fraction. Flipping the fraction following the division symbol. Okay, so we got 5 halves. We change the divide to multiply, and we flip this fraction. So this becomes 15 over -8. Now I'm going to see if I wrote it down right. 5 halves divided by -8/15. Yeah? Okay. After you've done that, then you simplify. Remember, if you can divide a number on top and a number on the bottom by the same number, do so. I don't see where I can divide anything or simplify any. So we'll go to step 3. Multiply the tops and multiply the bottoms. Five times 15 is 75, and 2 times -8 is -16. And again, if you've done a good job of simplifying, there's no simplifying here at the end. If there's enough room for this one or not, let me see. Yeah, maybe. I've got 12/10 divided by 24/15. Now again, we never actually divide, we immediately rewrite as multiplication. So I'm going to rewrite the division as multiplication and flip the second fraction. Take the reciprocal of it. And that's step 1. Now step 2 is to simplify. Try this again. Okay. Okay, simplify. If you can divide a number on top and on the bottom by the same number, do so. Well, here's 10 and here's 15. Those are both divisible by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So that's going to give us 12 over 2 times 3 over 24. Now again, we're still simplifying. So if you can divide a number on top and a number on the bottom by the same number, do so. Here's 12 and 24. Those are both divisible by 12. 12 divided by 12 is 1. 24 divided by 12 is 2. So this becomes 1/2 times 3 halves. Now it doesn't matter what order you do these in. You're going to find that you'll get the same answer. There's nothing else I can do, looks like. So multiply the top parts together and the bottom parts, and our answer will be 3/4. If you had started off reducing the 12 and 10 and 15 and 24, and then went from there, you would have get the same answer. So there is no right way, just as long as one's on top, one's on the bottom. Tablet going again here, and let's take a look at this one. I've already mentioned this before. If you're going to multiply, divide, add, or subtract fractions, they both should be fractions. So I'll rewrite the -3 as -3 over 1. Now I want to immediately rewrite this as multiplication. So that becomes times, and this becomes 6/5. And I seem to be choosing a lot here that don't simplify, because I'm at the step where it says simplify, and if a number on top and a number on the bottom both divisible by the same number, do so. Well, there isn't any. So now I'm going to multiply top parts together. Negative 3 times 6 is negative 18, and 1 times 5 gives you 5. And that's our answer. Yeah, let's look at this one. We got 3 sevenths minus negative 11 sevenths. Well, remember our shortcut. Negative parentheses negative becomes a positive. And we got 3 sevenths plus 11 sevenths. Now this is adding fractions with the same denominator. Now, you always apply those shortcuts with the signs anytime you run across them. Just makes your problem a lot easier. If you got the same denominator, then you're going to actually, let me put adding, subtracting fractions with the same denominator. Our first step is to either add or subtract the tops, the numerators, and put it into a single fraction. Okay, so these have the same denominator. So I'm going to add top parts. So we got 3 plus 11. So that gives us 14 over 7. And then our second step is to simplify the fraction. Reduce. If you like that term better. Well, 14 divided by 7, that's real simple. It just gives you 2. So that'd be your answer. Now, not all of them have the same denominator. So let's take a look at this one. We got 2 minus 2 fifths. And this is going to be adding or subtracting fractions with a different denominator. So adding or subtracting fractions with different denominators. Well, our first step, figure out the LCD and rewrite each fraction with that denominator. Well, in this one, again, if I'm going to subtract fractions, they both should be fractions. Now, if one of them is a 1 and the other one's a 5, your common denominator, least common denominator, will be the 5. The 1 doesn't come into play at all. Now it says rewrite each fraction with that new denominator. My second fraction already had a 5, so that's fine. We'll leave it as is. Our first one, we multiplied the bottom part by 5, so we have to multiply the top part by 5. Whatever you multiply by the bottom, you have to multiply by the top. So that gives us 10 over 5 minus 2 over 5. Then our second step is we're going to add or subtract the tops. And put into a single fraction. So add or subtract tops and put into a single fraction. Well, 10 minus 2 gives us 8. So we'd have 8 fifths. Now I'm going to circle this because we're technically done with that one, but our third step would be to simplify the fraction. Reduce the fraction. You'll see different books call that different terms. But this one can't be reduced, so that's our answer. Okay, let's look at another one. So it'll be a little bit more exciting. So we've got negative 1/4 plus negative 5/18. Now here we got a plus parentheses minus. That becomes a minus 5/18. And these have different denominators, so we need to get a common denominator. So for our LCD, we got 4 and 18. And remember, we do the prime factorization of each one. 4 is 2 times 2. 18 is 2 times 3 times 3. And our LCD, we look for the greatest number, which are the first prime, 2. We're looking for the greatest number of 2's in a single line. We got 2 2's here and 1 2 here, so the greatest number of 2's in a single line is 2 of them. Then we go to the next prime, 3. I'm looking for the greatest number of 3's on a single line. There's none here, there's 2 here. So the greatest number of 3's on a single line is 2. Well, that's 4 times 9, which gives us 36. So we're going to rewrite each fraction with that new denominator. Now the first one here, we multiply the bottom part by 9, so we have to multiply the top part by 9. So we got negative 1 times 9. This one we multiplied by 2, so we multiply the top part by 2. Well, negative 1 times 9 is negative 9. 5 times 2 is 10. And then we need to combine together the top parts. Negative 9 and negative 10 is negative 19 over 36. And our last step, there's no simplifying to do here. That's as simple as it gets. Let's take a look at one more. Let's start a new page. So we got 11. And we got 11/6 minus 7/4. Okay, so we want to figure out what our LCD is. So we'll look at 6 and 4. 6 is 2 times 3. 4 is 2 times 2. For our least common denominator, we start with our first prime, the 2. We're looking for the greatest number of 2's on a single line. There's 1 here, there's 2 here. So the greatest number of 2's would be 2 of them. Then we go to the 3, and we're looking for the greatest number of 3's on a single line. There's 1 here, none here, so it'd be 3. 2 times 2 is 4, times 3 is 12. So our least common denominator would be 12, and that's what we'll rewrite each of these with. Now in our first fraction, we multiplied it by 2 to get the new denominators. We have to multiply the top part by 2. Whatever you multiply by the bottom, you have to multiply by the top. In our second fraction, we multiplied it by 3 to get our new denominator, so we have to multiply the top part by 3. Well, 11 times 2 is 22, minus 7 times 3 is 21, and since they have the same denominator now, we can add or subtract the top parts. 22 minus 21 is 1. And our last step would be to reduce this fraction and simplify it, but that doesn't simplify any. So 1/12 is our answer. Well, let's get into some decimals. I don't like these very well, but we'll go through them. We got negative 12.7 plus 14.5. What they're trying to indicate to you here is all of our rules still apply here. It doesn't matter with decimals. They're exactly the same as we have been. A negative parentheses negative becomes a positive. So we got 12.7 plus 14.5. Now it's best to do these in vertical format. We'll line up the decimal places. 7 plus 5 is 12. So put 2 here, carry the 1. We're adding just like normal. 4 plus 2 is 6, plus 1 is 7, and 1 plus 1 is 2. Now our decimal place will be, our point will be right here, right straight below it. So 27.2 is our answer. We got 84 minus 3.72. And I'm going to set this up in vertical format. If I were to put a decimal for the 84, it'd be right here. So there's our 3.72 minus. I'm going to put zeros here, just because the same amount of digits I have down here, I want up here. Well, we can't subtract 2 from 0, so I have to go borrow. So I come here, there's nothing to borrow, go another one over to the 4. I'm going to borrow 1 from that, so that goes to 3, and then this becomes 10. But that's not where we needed it. We needed the next one over. So we're going to borrow 1 from that. And that goes to 9. And this becomes 10. So then, 10 minus 2 is 8. 9 minus 7 is 2. 3 minus 3 is 0. And then 8 carries down. So 80.28 is our answer. Let's take a look at multiplication. So we got 4.2. And I should have had parentheses around that because that may look like a decimal place. And then multiply it times 11.3. Well, I'm going to put 11.3 up here, and I'll put 4.2 here. I like to put the one with the least amount of digits down below. There's only 2 digits there. Okay. 2 times 3 is 6. 2 times 1 is 2. And 2 times 1 is 2. Now, I'm going to move on to my next digit. But I'm going to put a 0 placeholder here, and then when I start this one, I want to start in this position. 4 times 3 is 12, so put the 2, carry the 1. 4 times 1 is 4, plus 1 is 5, and 4 times 1 is 4. Now add these together, and we've got 4746. We have 1 decimal place here, we have 1 decimal place here, so our answer is going to have 2 decimal places. So that's our answer. And last torturous decimal. I don't like decimals. We got 27.2 divided by 8.5. Well, we set this up in division. We got 8.5 there and 27.2 here. We don't want any decimals out in front. So this decimal, move it 1 place to the right. And I also have to move this one place to the right. And now to get rid of our decimal out in front. Now we don't care about decimals underneath the division. We'll actually probably need to put one here, because I assume we'll have decimal places. Now 85 doesn't go into 2, doesn't go into 7, but it does go into 272. I think 3 times. 3 times that is 15, carry the 1. 3 times 8 is 24, plus 1 is 25. I'm going to subtract those. That gives me 17, I think. 65, 72, yeah. Okay, now I need to add a 0 here, and then put a 0 down here. And 85 goes in that 2 times. 0, 1, 170. And when I subtract those, that gives me 0. That 0 there means we're done. Now here's my decimal place. The answer will have a decimal right straight above it. So our answer to this problem will be 3.2. And I believe that's the last one in that problem, or section, so we're all done with that.